Hi everyone, welcome back. So Codeforces question for today is little girl and maximum sum. This is tip 2C problem. It is 1500 rated. This is a very interesting question, and also such questions are very common in online assessments because one question is definitely there where you are given Q queries and L and R, the index from where to where the query will run, and then brute force approach does not work for that. You always get TLE, we have to optimize it, and we are unable to find the optimal solution for that. So today's logic will help you there because this logic is mostly used to solve such query questions. So we shall see now what's the question. So the little girl loves the problems on arrays queries very much. One day she came across a rather well-known problem. You've got an array of n elements. The elements of the array are indexed starting from 1. Also, there are Q queries. Each one is defined by a pair of integers Li and Ri, where they are in the range 1 to n. So we need to find for each query the sum of elements of the array with indexes Li to Ri. So we have to find the sum of elements from L to R. Both are inclusive. The little girl found the problem rather boring. She decided to reorder the array elements before replying to the queries in a way that makes the sum of query replies maximum possible. So the sum of replies have to be maximized by reordering the array elements. And our task is to find the maximum value possible of the sum. So this is what we have to do. So we have to find the maximum sum. And what we can think of is that we are given Q queries, we have to do the sum for all L to R. So if this was without reordering, we would have thought of a brute force that we shall do for every query L to R, we shall put a loop and get the sum, and for all the queries we shall get total sum. That would have been our answer, but that was boring. So the question is now interesting as we can reorder the array elements, and now we have to maximize. So how shall we do this? One thing that we know in this question is we are given queries from L to R, and the indexes that will be used the maximum number of times in L to R range means the indexes count we have to get which index is coming how many times in the total queries, and the index that will be coming the maximum number of times we have to keep the maximum element there so that it will be multiplied and give us the maximum sum. Second maximum time coming second max, so we have to get the number of times each index is coming in our queries. That is the first thing that we can think to maximize. We have to get that, and after that what we have to do, we just can sort it so we get in order, and we have to sort our original array so that we get our original array in order, and maximum element we'll keep on the maximum time, then the smallest one to the smallest number of times. So this is the basic idea for this problem to solve it. But how shall we do this? Again the question comes the same. We can find out which index is coming how many times, but if we put a loop for every L to R and increase the frequency of that index, then our queries are 10 to the power 5. L and R can be also 10 to the power 5 whole range. So for Q queries, if we put this, it is 10 to the power 10. This will go in out of bound, out of time bound, which means it will give us TLE. Brute force shall work for some cases, but we are finally going to get TLE. So this is the main thing in these questions. So how to optimize that? We shall see how to optimize that. So for L to R, one thing we can see that for L, our index frequency increases, and after R that index frequency decreases. So we can keep an array. For L we can add 1, and for R we shall subtract 1. And then if we do the cumulative sum for that array, we shall convert it into our frequency array for each index. This is the trick for these questions, and we shall use the same to solve it. think about it. Moving to the solution. So we have taken n, then q, n is the number of elements, q is the number of queries, then array A, n inputs. We have taken n inputs in our array A. After that, we want frequency of indexes, which index is coming how many times in the range. So we have kept a frequency array and we have kept it n plus 1 because r is included. So we have to do that plus 1 index. We need to subtract after r. So we need plus 1 index, extra index to subtract it. Otherwise we'll get index out of bound error. Now for Q queries, we shall take the input. These are one index, so we shall subtract 1. R we already had to include, so it is fine. It is already ahead one step. So L and R we have taken. Now what we had to do, we had to increase for L. Increase the frequency for L means this range starts at this L index. So we had increased the frequency of L, and at R this range ends, so we have decreased the frequency of R. Now finally what we have to do to get for every index, we shall do cumulative sum. When we do cumulative sum from 1 to nth index, so fi is equal to fi plus equal to fi minus 1, means we are doing cumulative sum. For one index we add 0 and 1, for 2 we add total 0, 1 and 2. So this is cumulative sum we are doing in this for loop. So after doing this cumulative sum, for each index we would have got a frequency. Plus and minus would have handled all our ranges. So instead of putting a loop for every time for L to R, we have just put one loop. So this optimizes this solution. For n numbers we have got our frequency for each index instead of applying that loop again and again. So this is the optimization. And one thing more to note is that at last, if we would have be having one extra element in our frequency array, and that would be storing, if it R is the last element, so at last that would be having one extra 0, because it would be balanced plus and minus. Out of range would be having extra 0, because range increases and then range decreases. So at last element it would be having 0 in the cumulative frequency. Positive and negative balance each other, so at last there has to be one 0. Life begins at 0, ends at 0. So now what we have to do, we have got the frequency of each index. Now for the maximum frequency we have to multiply the maximum element, so we have to sort both our arrays. So we have sorted A, we have sorted frequency array. Now we have to get the sum of all the queries, so we have kept a variable sum. Now we shall put a loop. After sorting f, we had one extra 0 that would be at the starting. So we are taking a loop from 1 to n. I is equal to 1 and I is less than equal to n. So this is for frequency array, and our array A would be 0 indexed. So we need to write I minus 1 for that. So we have handled the extra 0. We have handled A. We shall put a loop. For each frequency we have to multiply that array element. So for the lowest frequency, we have to multiply the smallest element for next higher and next higher. So this shall give us the maximum sum. We have multiplied one L to convert this into log if the product goes out of bound. And after this, we would be having our answer in the sum. So this was the solution, optimal solution for this question. We shall print it. But one thing to see in this is the Java problem on Codeforces. That is, Java is a bit slow, and it sometimes the correct solution also sometimes gives a error TLE on Codeforces, which you might not encounter in C++ or Python. We shall see that. So when I submit it and check the status, So when I see my previous submissions, so this was my submission. See, this is the same solution that I've shown you guys, and Java 21 is selected and it gives me TLE, although it is perfectly in range as we are doing sorting 10 to the power 5 whenever we get constraints. Only approach we can think of is sorting or binary search. This is the fixed thing. It is in bounds, but it's still I'm getting TLE. Now we shall see the same solution I have submitted for Java 8. See, the same solution for Java 8, and it is completely accepted. So this is sometimes you might encounter a problem in Java, so be aware. If your solution is in the range, then try changing the Java compiler. That would work. So this was it for today. Thanks for watching the video. I hope you guys would have understood the approach. Have fun. Bye.